So, horrible segue, let's do another problem. Now, I know you're going to love this one. Parabola and absolute value. You say, like, could it be? Are they teaming up? Is this some kind of awesome mathematical alliance? I cannot wait! Yeah, it's the Justice League of Mathematics. Awesome. Yeah, can't wait for some famous mathematicians to show up. You know, get some Leibniz in here, some Newton, Descartes. I know you like Descartes, right? Of course you do. He's the one that kind of helped develop this, the Cartesian coordinate system. He's French, René Descartes. Now, let's make this guy our number one guy. Tell me everything you know about number one. What's stretched, though? It's the absolute value shape, and it has been stretched. What tells you it's been stretched? It's been stretched by a factor of 2. And then what about its position for the vertex? So the vertex is -2, -6. We have that information listed. That takes care of the up, down, left, right. Now talk about the inequality aspect of this. What tells you solid? Equal to, and then we're going to shade where? We'll just shade below.
Sorry.
No, you're fine. You're good. Now let's look at number 2. Tell me everything you know about number 2. It's an upside down parabola that has been compressed. It's by a factor of 1/2. So it's going to look a little bit shorter and squattier. What is its vertex?
1, 4.
All right, so that should be enough for the graph. What about its inequality parts? It's going to be dashed whenever we graph this guy. That's going to make it super fun, right? And we will shade greater than, so that means above. You list all of the information that you have about these guys before you graph them. Question?
No.
She says no. We shall move on. All right, so let's talk about this absolute value. Vertex is -2, -6. Open or close point? Close because it's included, because it's solid. It's stretched, so it's got that slope of 2, up 2 over 1. And we go back the other way as well. All right, so I've got my shape, I've got the stretch, connect the points. And then connect it going the other way. How do you guys feel about that? Now, here's what I want you to know. What we just graphed right here would have been a small, small component of the homeworks and the tests that you've already done, right? And look how quickly we did this. I hope that by now we're getting this. And if you get this now, when you take college algebra next semester, it's going to be super easy if you remember all of these graphing techniques. And if you don't remember them, guess what you could do? Watch the videos, yes. Well, what if I forget your YouTube address? Then you can put it in your favorites. Subscribe. Subscribe now. Click below. Of course, I guess that means I need to create some kind of link for you to be able to subscribe. Anyway, so I need a shade below, so that means I'm going to be shading which side of this? Here? No, down below, right? So I'm just going to put a few arrows down here so I know I'm shading below this guy. Is everybody okay with that? Yeah. Now for the next part. A parabola with a compression. How exciting. Where's its vertex? So 1, 4 is right here, open or closed? Open because it's dashed, so I've used that guy. Now, get your points in the right spots. 1 squared is 1, right? But am I going to put it here at 1? I've got the compression of 1/2. 1 squared is 1, but half of that. 2 squared is 4, but half of that is 3 squared is 9. What's half of 9? 4.5. 4 squared is 16. Half of 16 is... I wonder if I can get another point on here. What's 5 squared?
25.
5 squared is 25, and half of 25 is what? 12.5. Sometimes you're just too good for me. I can't even keep up with you guys. So reflect all these points back over here. Wait a minute. There we go. So there's my shape. Need to make this guy dashed. Well, that's not too bad, is it? Dash, and I need to shed above. So I'll look at a point right here. Shedding above is going to be above this way. So what's common in their shaded regions? Where do they intersect? Find where the arrows are pointing towards each other. What do you have?
This side and this side.
Yes, this side and this side. Right here, see how they're both pointing? So it's going to be this piece. What about the point where they intersect? Is that included or not?
They're not both solid.
They're not both solid, so it's going to be an open circle at that intersection point. Do they intersect right here? How about right here? No. How about here? How about here? Yes, see they're both pointing. You're going down here, above here. So you have two regions. And here's the thing about these regions. These guys are never going to be one whole region. They're two separated regions. So please do not get in the mindset of thinking that it's only the completely enclosed section that's the intersection, because it wasn't here. So what do you guys think about this? Love to see that on the test next week?
Can't wait.
Can't wait. Okay, well maybe I'll give you a homework assignment for this